In today's video, we're going to look at the pH scale and see what acids and alkalis are. pH is really just a measure of how acidic or alkaline a solution is, and it's measured on a scale from 0 to 14, with low numbers being most acidic and high numbers being most alkaline. And if the substance is neutral, like pure water, then the pH would be 7, which is neither acidic nor alkaline. To give you some idea of what all of this means, the acid in your stomach, which helps you to kill bacteria, has a pH of around 2, while acid rain is around pH 4. Then for alkalis, washing up liquid has a pH of around 9, and the bleach we use to clean bathrooms has a pH of around 12. Be aware though, you don't have to remember these specific examples, they're just to give you some context. Now we can measure pH in a couple of different ways. One is to use some kind of indicator, which are a group of chemical dyes that change colour depending on the pH, and different indicators will change colour at different pHs. Some indicators contain a mixture of these different dyes though, so their colour will slowly change across a wide range of pHs. So we often refer to them as wide range indicators. The most common example is universal indicator, which gives the colours we've shown on our pH scale here, ranging from deep red at a very low and acidic pH, to yellow, green, and then bluey purple as we increase the pH and it becomes more alkaline. The other way to measure pH is to use a pH probe connected to a pH meter. By dipping the probe into a solution, we can electronically measure the pH and get a numerical reading on the meter. The benefit of the probe compared to an indicator is that it can be much more accurate and precise, because it doesn't involve humans guessing shades or particular colours. And as a general rule, measurements that remove the need for human judgment are going to be more reliable. The next thing we need to look at is what exactly makes something an acid. You can define an acid as any substance that forms aqueous solutions with a pH of less than 7. And the reason for this is that acids release hydrogen ions in water, which make the solution acidic. On the other side of the scale, we have bases, which we define as any substance with a pH greater than 7. Meanwhile, alkalis, which we mentioned before, are actually a subgroup of bases that are soluble in water. So we would say that an alkali is a base that dissolves in water to form a solution with a pH greater than 7. And these alkalis form OH- ions in water, which we call hydroxide ions. If we react an acid and a base together, then we get a neutralization reaction, which will always produce a salt and water. For example, hydrochloric acid plus sodium hydroxide, which are the most common acid and base, will react to form sodium chloride, which is a salt, plus water. Another way to show these neutralization reactions is in terms of hydrogen ions and hydroxide ions, where H+ from the acid and OH- from the base combine to form H2O. And because the acid and base have both been neutralized in these sorts of reactions, the pH of the products should be 7 because they're neutral. Before we finish, I just want to point out some of the common acids and bases that you'll come across in the course. The main acids are hydrochloric acid, sulfuric acid, and nitric acid, while the common bases are generally hydroxides or carbonates, like sodium hydroxide or calcium carbonate. There are loads more, but it's definitely worth learning these few, as they crop up a lot. Anyway, that's all for today, so hope you enjoyed this video, and we'll see you next time.